cruising all around. Adding vectors today. It's a pretty easy lesson. All right? Just make sure you guys are staying on top of it. Need you to define the resultant. That's in your textbook. Here we go.
What? I just gave you a
Okay. So, volunteer, what's the resultant? Lucy? What's that? Sum of two vectors. Well done. Okay, sum of two vectors is a resultant. So that means you need to actually know what a vector is. Remember, our vector, we have an xy axis. You have a vector. Okay, and then we have another vector, say like this vector here. If we put those two together, so if I move this one upward, just attach it to the end there, the sum of those two vectors is the resultant. That would mean if I found the distance from this point to that point, that line right there would be our resultant. Okay, that distance, okay, that coordinate would be the location. Thank you. That coordinate would be the location. All right. Now we're going to go through that today. Just keep in mind that naming a vector, the way we name a vector, for instance, if we're saying vector A, that wouldn't be done like that. It's the arrow without the other part of the arrow. Okay. Questions? All right. So here's what we're going to do. I want you to look at the example side of the assignment that you picked up on the way in.
Did we?
You should have. I think you did.
I don't think I did.
Okay. And we're looking at problem number one. And problem number one, find the sum of each pair of vectors. Give your answer in order pair notation. So what I need you to do is do your best right now on problem one, based on what we just talked about the resultant, how you attach these vectors together. I want you to find the coordinates when you find the sum. What are the coordinates of the sum of these vectors? Attach them, put them together, and find out where they end. Work with your groupies. Do what you think you should. A number. That number corresponds to the number you use for your test. Person number 3, you get the opportunity to answer it. This is when your groupies, knowing the answers, will really pay off. What do you think, Trevor? Don't know. Okay, we'll go on. We'll try another one. Number 13, Maddie.
Hello, do you know? Hey, group. Hey, group, do you guys know?
No, it's not the whole group. You get an answer, but...
All
right, let's pause. Let's pause. So what we're doing here happened. Person number 20, Gracie.
Well, don't you have to connect them and then find...
Yeah, let's connect them. That's a good start. So this one right here, let's slide that one up. Okay? So we're just going to attach it to the end. All right? So the best way to do this, other than freehanding it, and especially for you guys, your paper's a little smaller, best way to do it is think from here, from the beginning, to out to that point right there is how far over?
3, 4.
It's a distance of 4. So from here, which you're at 3, you should go over to? You go 4 over, which is how, where do you go to? Negative 1. Okay? And then how much do you go up? 1. So you go over and then up. Okay? And so now if I were to connect those, you'll notice that they should look pretty parallel. Pretty close to parallel. All right? Where are you at? Eli? Negative 1 and 4. That is the resulting vector.
Oh, God.
Okay?
We get a point.
Yeah. Yes, Gracie got one. You got one. Okay? Everyone try number 2. That'd be Jody.
7, 6.
Jody says 7, 6. How many agree? 7, 6. Okay? Yeah, and so from this, like if I'm attaching this one, if I'm sliding it over, I have to go over 1, 2, right? And so from here I go over 2, so I'm now at 6, and I go up 1, 2, 3, 4, and so I go up to 4. Looks like it is right there. Now that doesn't look right. Did I not go up far enough?
You have to go up 4 from 2.
What's that?
You have to go up 4 from 2, right?
Oh, from here. Thank you. Unbelievable. All right. Yeah, Maddie corrected me, so you guys get a bonus point.
Yeah.
I'm just saying.
Yeah.
Are you keeping track of
Okay.
points?
Huh?
We have 2 anyway.
All right. So now that's not an amazing job, but here's my resultant, right? That resulting vector is at 6, 6.
6.
She said 7, 6.
7, 6. Did I go wrong?
Yeah.
You sure? Oh yeah, it's 7, 6. Thank you. Thank you.
We corrected
All right.
you.
Well done. All right. Yeah, but Maddie was nice about it. Okay. All right. And Jody gets a point back there. Well done. Okay. Any questions? Thank you, Bennett. Okay, I want you to spend a few minutes making sure that you guys understand what's going on there. And then after you're done with that, I want you to look at number 10. Talk to your neighbors about how you're going to do number 10. Hey, I realize everyone's not done quite yet, but I want to talk about how to find y first. All right? So y. Let's go. Mitch, what do you got for y?
For y, I'm not done with y.
How am I going to find it, Mitch?
You're going to use
All right, hold on. We'll go on. Number 22. That's Brianna. Bree, how are you going to find y? No. She can do it. The Pythagorean Theorem. So the Pythagorean Theorem, Brianna, is what? Okay, and so if we do that, we're putting in, what's C? 30. Okay, and what's A? 15. And we're trying to find B. So in this case, we're calling B Y. All right? So what did you end up with? Yep. 675. Anyone have a second there?
Oh, square root it.
Yeah.
Root 675.
Root 675?
Yeah.
Okay.
Which is 26 because it's 25.98.
Okay. Hey, can we simplify root 675? Let's go with person number 1, Anna.
15 root 3.
Yeah, so that is root.
Sorry.
Root. So when you say 15 root 3 at root 9, is that where you're going? Or no? Root 225 by root 3. And 15, this is 15 root 3. Okay. Okay, that's right.
But you have to round to the nearest 10th.
Yeah, I didn't.
Oh, don't simplify. Oh, so round to the nearest 10th. What do we get?
You maybe do extra work. 26 points.
Eli,
26.
quick on the draw. 26? 0.0. Okay. Very good. Huh?
Miles an hour.
Yeah, we don't get points for correcting that. All right. Anyone find X?
Yeah.
Man, we got a bunch of people. Okay, just wondering. Hold on, I gotta give points here.
Yeah,
All
we got like 5 points.
Okay, person number 12. Who's 12? Amy. How do you find X?
So you put sine x equals 15 over 30.
Sine X equals 15 over 30.
And then you do x equals,
Hold on, how do you know it's sine?
because you have opposite and hypotenuse.
Good. You have opposite, and you have hypotenuse.
And then x equals sine negative the opposite one.
The inverse sine.
Yes. And then sine 15 over 30.
Okay. So what do you get? That's 1/2, which is
30.
that's a special that's a special angle. The 30, 60, 90, 45, 45, 90s. You'll memorize those when you get to advanced algebra next year. Okay? So anyway, that's a special one. Very good. How many got it? Yeah? Question?
Oh, well, yeah. It wasn't. So I did the same thing. I messed up. But I did like sine negative 1, 15 divided by root 675. And I got 32, which is like weird because it's completely weird.
You did.
How do you even
Yeah, I don't
I
know.
don't even know how that worked, but I got it. It's weird.
Yeah, you shouldn't have got that.
I shouldn't have got this.
No.
Um,
Okay, any questions on it? Everyone rate themselves 1 to 5. Okay, one last problem. Number 7. The mixed side. Everyone turn to the mixed side. Just copy the diagram and then draw the parallelogram that has the given vectors as consecutive sides. Then draw the resultant. Okay, so let's look at number 7. We're going to work through this one together. Note that on this one, here's a vector, and then this vector is just kind of lying here. You can barely see it, but it's labeled. So what you're doing is you're trying to draw a parallelogram out of it. Okay? So if I move either this one over or this one up, I'm going to have to do both of them eventually, but if I just slide this, and it's nice if you have a straight edge. Notice how I'm trying to keep my side that I'm sliding parallel the whole time. Just slide it over, then draw that vector. Okay? Now, if I take this vector and slide it up, there's my parallelogram. Draw the resultant. Tell your neighbor what the resultant is.
It's the sum of the two vectors.
Okay? Can someone give me a good description of where the resultant is? Bennett?
Is it where the two that you just drew, is it where those two meet?
Yep, very good. It's where those two meet. Okay, your resultant is right at the tip where those two meet. So it says, then draw the resultant. That is the resultant. It goes from the origin out to where those two meet. This is the line you're trying to draw at the end. Okay? Any questions? Nick? That's all you need for that problem. We've done it all. All right. Very good. That's it? Yeah.
Do vectors have arrows on them?
Vectors do, yes. Yeah. Like these little arrows.
Yeah, why?
Because a vector is actually a ray that extends out from the origin and rotates around.
So when
Okay,
they
so
find-
it goes on forever.
Then why do we have a certain length for it?
Yeah.
We have a magnitude of that vector. That means where we're ending just that chunk of it.
Okay.
Okay, but it actually would extend. It's still a ray extending out.
Okay.
Okay.
What is log?
The assignment, mixed side, all. You know what? I got so wrapped up and I forgot to show you the easy way. So the winning team, since you guys won, how do you do it? Go ahead, Nick. Yeah, you add the coordinates. So this vector ends at the ordered pair 2, 4. And this vector ends at the ordered pair 5, 2.
So it's just at the very, very tip of the arrow, right?
Yep, very tip. And so to find the sum of the vectors, all you do is take 2, 4,
Add them.
add it to 5, 2, and your answer is 7, 6. That's where it would be. You don't have to draw it every time. Okay? So once again, the easy way, add the coordinates of the vector.
What side?
Very good. Mixed sides are your sign.